Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have been discussing about the chapter Units and Measurements, and we have already discussed what a physical quantity is, what you actually mean by measurement, and what is actually a unit. And also we have discussed about two major categories of physical quantities, that is fundamental physical quantities and derived physical quantities. So I hope you have all remembered these things. Okay, so in today's class we are going to discuss in details about the system of units. First of all, in the previous lecture we have already discussed what is actually a unit, and we have said that unit is nothing but a standard quantity with which any other physical quantity is compared. Criteria is there that the quantity with which you are measuring should be of the same nature. Okay, so discuss these things. Now, what was the requirement for the unit? So that objective is already clear. Now, today we will be discussing about the system of units. System of units. Now, you must be wondering, so we have already discussed what a unit is. So in order to measure the length of certain things, definitely you can consider a string in your house as the standard length and measure any length with the help of the string by comparing the length of that object with the length of the string. Yes, very sure, very nice. But what will be the problem? The problem actually lies in the fact that that unit that you are choosing is not a standard unit, is it? It is not a standard unit. The length of a string might be known to you or to some of your very close friends, or say some of your relatives, or to your father and mother, but actually that length that you have taken as the standard is not known to many others. For example, say if you have a friend who is living far off from your home, do not know what is that actual length of the string that you have taken as the standard and which you are comparing certain lengths. So here there was a requirement field for standard units, and from there it gave rise to the SI system of units. Okay, so when you need to standardize the system of units, the SI system of units was introduced. SI units. Okay, so I think the concept is clear. This is a French term, Système d'International. In English, actually, we refer to it as International System of Units, but the term SI comes from the French term Système d'International. Okay, so SI system of units was actually a standard unit which was to be followed by scientists or by educationists or by for any scientific purpose or any measurement purpose by people from all the countries. Okay, so for any major international calculation or international say some research, okay, we always follow the SI units, the standard system of units or the international system of units. Okay, so as we have discussed in the previous class that there are certain fixed number of fundamental physical quantities. Okay, and I think you have remembered, as you have said, there are 7 plus 2. Those two are the supplementary 7 fundamental physical quantity. Along with that, other 2 are the supplementary fundamental physical quantity. Okay, now, so if you know the SI units of this particular 7 plus 2, that is 9 fundamental physical quantities, you can definitely get the SI unit of all the other derived physical quantities. So today, so here we will be discussing, or we will be just exactly pointing out what are the SI units of those 7 fundamental physical quantities as well as the 2 supplementary fundamental physical quantities. Okay, so you can write with me, so it will be a nice practice for you. So here I write physical quantity, and here I write the unit. Okay, so let us see what are those units. Okay. So now the first physical quantity is length. So length has an SI unit of meter and the symbol used is small n. Okay. Second is length mass. SI unit is kilogram, not gram, rather it is kilogram. So symbol we use is kg. Third is length mass time. So for time the SI unit we use is second, denominator small s. Fourth, temperature. Now in many of the cases for maximum practical uses in our daily life we use the unit of temperature as degree centigrade, but the SI unit is Kelvin, so it's capital. See that when we write the unit Kelvin in full form, we write it in small letters. There are certain rules regarding the writing of the units. We will be discussing it later. Just remember, when you are writing it in full form, they must be in small letter, and the abbreviated form, if it is named after any scientist, then it should be in capital, else it should be in small letter. Okay. So length, temperature. Fifth is current. So current, for current it should be ampere. The symbol that we denote is capital A. So just let me draw a line so that the sequence does not get confusing. Okay. Sixth one is luminous intensity. Luminous intensity. So it is candela. We have discussed about this luminous intensity, physical quantity called luminous intensity, and I think you remembered it's the physical quantity which is denoting the intensity of any light source. Okay, sorry. So I think now you'll be able to see it. Luminous intensity. Fine. Okay. Another SI unit left to be written. It is the seventh one. So the seventh one is amount of substance. Okay. So amount of substance is actually denoted by SI unit is mole. MOLE. You'll be reading this in chemistry. Short form is MOL. Okay. So this is the seventh physical quantity and the respective SI unit. So I think okay. So here is the amount of substance denoted by letter mole. Okay. So it is clear. Fine. I think you have noted all the SI units and the physical quantities. If not, please pause the video and note the units. Okay. Fine. So we will be rubbing it off. Okay. So these are the 5 fundamental quantities, 7 fundamental quantities, and their respective SI units. Okay. So we have another 2 supplementary fundamental physical quantity. What are those? Those are the angle and solid angle. So for angle, the SI unit that we use is actually not degree, rather radian. So 8th one is angle. The SI unit of angle is radian. Short form is written as RD. And 9th is solid angle. So it is, the SI unit is stay radian. Okay. Stay radian. ST radian. Okay, fine. So these are the 9 fundamental physical quantities and the respective SI units. Okay. So I think the system of units is clear. Now you can, using this units, you can get the SI unit of any other physical quantity which are actually derived. Say if you want to determine the SI unit of speed, SI unit of volume, SI unit of density, so just write the formula. Say for density, What will be the formula? You know the density, formula of density is mass per unit volume, isn't it? So SI unit of mass is kg. SI unit of mass is kg. So this is kg, and the SI unit of volume is meter cube, isn't it? So actually the density, SI unit of density is kg m to the power minus 3. So this is the SI unit. Okay, so like this you can get the SI unit of any other derived physical quantity. Okay, so we have already discussed about the various SI units and their symbols, their names. Okay, so this is it. Now next we can classify the physical quantities into another two categories. So physical quantity can also be classified as, we have already discussed, fundamental physical quantities and derived physical quantities. The other two categories are, one is this scalar physical quantities and another is vector physical quantities. So you might be wondering what are these two physical quantities, scalar and vector. So it's very easy. Scalar physical quantities, see, there are certain physical quantities, like when you say you go to a shop and you say to the shopkeeper that you need say 5 kg of sugar. Now while saying this, do you need to specify any direction while you are specifying the mass of the sugar? I don't think that you need to mention any direction. You just plain you say 5 kg of sugar, the shopkeeper gives you give the price and you take it and come back to home. Okay, so you do not need any direction. But there are certain physical quantities, say when you are saying that you know about the physical quantity called force. Yes, you all of you have a brief idea about that. Now when you are talking of force, remember one thing, say the earth attracts us with a certain force, you know this, that is why we are staying connected with the earth. Okay, and that force is called the gravitational force. So when you talk of gravitational force, basically the earth is attracting all of us, all the objects on the earth towards its center. So definitely force has a direction. So when you say that the earth is attracting us with a certain amount of force, we also need to specify the direction. Towards which direction? Pulling towards the center. So this kind of physical quantities, actually there are the direction is also very much important along with the magnitude or the unit. So this kind of physical quantities that have certain magnitude, unit as well as the direction is equally important, this kind of physical quantities are called vector quantities. So I think the classification of scalar and vector is clear. Scalar quantity do not require any specific direction, but the vector quantities require direction to specify them. So this is another way of classifying the physical quantities. Okay, so I think the concept is clear. So today we will be ending our class here. We have already discussed about the main topics about the various physical quantities, their units. In the next class we will be discussing specifically about the physical quantity length, physical quantity mass, physical quantity time, and their various units that we use. Okay, so till then, in the next class we will be discussing. Please till then to study well, and if you have any query, please do mention it in the comment box. We will be happy to solve your queries. Okay, so till then, thank you, goodbye.